Их презентации пока здесь нет. Говорят, они онлайн. И их здесь нет. Соединились. Если их не будут, то вместо них будет презентовать первыми ID 99 и 100. И все, дальше по списку только ID 43 присоединяется. И вот ID RIM вот здесь видим.
Всем интересно. Кому интересно, можете, если человека 2-3, наверное, идти.
Да, ребята, у нас места не хватает.
Вот, гостям места не хватает. Кому вот не интересно, кому интересно, мы не гоним. Пожалуйста, оставайтесь.
Не знаю, у нас первая часть, она длится до 4, вторая часть начинается от 4:20 и до 6. Ну, okay, speakers, this one is section number 4 on the IEEE conference, and this section is about data science and advanced analytics. And we are going to start at 2:30 by local time, and our section is will be until 4 p.m. It means that we have overall 11 speakers, and for each speaker, we will give by 6 minutes and 1 minute additional for Q&A. And the first thing is, let me ensure that all of the speakers are over here or online, and let me check one by one. So speaker ID 16 and 19, as far as I know, you are here, right?
No, 16 and 19, I am going to present.
Yeah, okay. You are going to start first. And
Okay.
During presentation, you need to turn on your web camera and share your screen.
Okay.
And let me check ID 24. Are you here? And the ID 28. And I do know that ID 43 is here, 63 is here, right? I get them. And the ID 89. No. ID 92. No. And the ID here. 92. Okay. And the ID 99 and the 100 is here. And the last one is ID 103. Okay, then we're going to start in 5 minutes. Then you can check your device and share your screen.
Free in advance.
Абсолютно. Я именно just онлайн да қосылған. I'm sorry, speaker ID 16, could you share your screen?
Miss Mira,
Yeah, yes, I'm here.
please share your screen.
Okay, shall I start now?
Yeah,
Okay.
we are waiting.
Yeah, we are going to start in 2 minutes. Now you
Okay.
can start sharing your screen.
Okay.
We need to see that all is okay.
Okay. Wait a minute. Okay. Is it visible?
Yes, it's visible.
Okay. Shall I start? Wait for 2 minutes.
I think that we can start. First, let me introduce you. The first speaker is ID 16, and his name is Mira. And as far as I know, here is written, you are from Germany, from University of Europe for Applied Sciences, right? Yeah,
Yes.
we are very welcome. You and you can start.
Okay. So, good afternoon, everyone. My name is Meera Karnanidhi. I am from University of Europe for Applied Sciences and Potsdam campus, Germany. And then my first paper is segmenting European beer consumer using k-means clustering. Sorry. Happen. So, okay, sorry for the. Okay.
I'm sorry, we cannot see your screen. Could you share your screen, please?
Really?
Yes.
Wait a minute. Now? Is it visible?
This going to show
Is it visible?
Yes, we can see you. Yeah, we can see your screen. Now it's visible.
Okay.
Yeah, now you can start.
Wait a minute because I cannot see my screen. Okay, now it's visible.
Since which
Okay. So my first topic is segmenting European beer consumers using K-means clustering. So these are my agenda. Then first, the objective of this paper is to identify distinct groups of beer consumers in Europe. So it uses K-means clustering to analyze the data such as beer consumption rates, GDP per capita, purchasing power parity, and demographics. And then it helps breweries and marketers to understand. It gives better understanding about their customers, and also it enables the data driven decisions for tailored marketing and product offerings. And then in the European beer market, the K means helps to identify not only the distinct consumer group, so based on the consumption pattern, the brand preferences and demographics also, we can analyze, and then it will help for their marketing and then the product quality as well. And it supports targeted marketing and customized product development. Then the K-means clustering in market segmentation. So K-means clustering is a popular and it's a efficient machine learning algorithm. It's unsupervised machine learning algorithm. It's for market segmentation. It's due to its simplicity, and then it's developed by McQueen in 1967. And the K-means partitions data into K number of clusters and assigning each point to the nearest cluster mean. And then this algorithm is following an iterative process, so it assigning the data point to the nearest cluster, and then it recalculates the distance between the data point and the cluster centroids, and then it repeats till no more further changes in the assignments. The goal is to minimize within the cluster variance, ensuring the clusters are internally similar. Then this is the process flow diagram. So it's a iterative process. Once the if it finds there is no more changes, then the process will be stopped automatically. So first it begins with K means clustering process. Then it picks K random points as a starting cluster sender. Then it assigns the data points. It grouping the data points closest to the center, and it calculates the difference between the center point and the data points. So and then if the centers the distance is minimum at it, if the data point is assigning within the cluster means, and then the cluster will be complete. Otherwise it will be recalculating the distance and then repeat the process till the cluster is complete. And this is the concept of Euclidean distance. So it is useful for recalculating the distance between the data point and the cluster center. So example like if we are taking the P is the first point means Q is the second point means, example like Q is the centroid means P is the data sample means. So first the formula measures the straight line distance, straight line between P and Q, and then this is how the K-means decides which data point belongs to which cluster by assigning each point to the nearest centroid. Then this distance to group similar consumers together, and it updates the cluster centers until the best segmentation is found. And the methodology, we use the Python, and then the Jupyter notebook is the background, and the libraries we use pandas, numpy, matplotlib, seaborn, and scikit-learn. And then we used two data set. The first data set contains a beer consumption, GTP, purchasing power, revenue, demographics, price, brand preferences. These attributes are main attributes, and then we consider these main features only. And then from the data set 2 contains episodic drinking patterns for people aged 18 to 64 and linked to health and economic data. And then the data sources are Brewers of Europe, Eurostat, WHO, Statista, European Health Interview Survey. And then first in the data processing, first we fix the missed values, and then we remove the outliers, and then we selected the important features like economic and demographic for clustering. Then exploratory data analysis, it is very important because from the EDA, so we can understand the data pattern and then the relationship between the attributes. So first we have done the exploratory data analysis. So it analyzes the data distributions, outliers and trends for guiding clustering analysis. We focus the key areas of beer consumption, economic indicators like example like income, GDP, and then demographic data like gender, age. Then outlier detection was performed to prevent clustering distortion. And then what are the statistical insights we found, we observed from the analysis means the average beer consumption is 64.12 liters per year, and the mean income is 20,000, around 20,000 euros. And then the gender distribution is 36.31 female rate and 63.71 percentage is male.
Remaining.
Yes.
1 minute remaining.
Okay. Just I'm okay. So we use the visual tools. Okay, so this is the correlation analysis. So we use the heat map to visualize the correlations. So from the heat map, we can understand the relationship between the attributes. So the positive correlations, it shows the strong relationship between the attributes. The negative one is the weaker relationship. So if it shows 0 means, so we cannot consider the attributes for the further analysis. So here the beer consumption is linked to gender, income and GDP, and then the higher male population and higher GDP lead to more beer consumption. Then the price increase might reduce daily consumption, and then there is a clear inverse relation between non-drinkers and beer revenue. And then this is the beer consumption trends and demographics. So the charts displays the popularity and frequency of various beer styles across the countries, revealing the consumer preferences. And then we plotted the kernel density estimation. So it is in the next slide. So it's used to visualize the distribution of beer consumption, income and GDP per capita. And then we identified the anomalies, which means the outliers. And we used 1.5x inter quartile range, which means we consider the anomalies like below quartile 1 and above quartile 3. And then these are the plots.
Yeah, could you
And then the
summarize
cluster.
it?
Yes.
Mhm.
So this is the clustering methodology, and then this is the steps of the k-means clustering. And then these are the clustering outcomes. So we used we used 3 cluster solution and 4 cluster solution. From the 3 cluster and 4 cluster, we identified the balanced segmentation of consumer group, and then it's more detailed segmentation, allowing deeper insight into consumption patterns and behaviors. And these are the visual analysis and insights and strategic implications. And then we have some limitations due to the lagging data lag, and then the factors like brand loyalty, marketing effectiveness and seasonal consumption are excluded. And then
Okay, thank you. Thank you very much. Time is
okay.
Yeah,
Okay.
and we have 1 more minute for Q&A. If you have
Yes.
online or in-person participants, if you have any questions, please, we're welcome. Yeah, could you come here and speak to the microphone, yeah. Okay.
Okay. Hello. I want
Yes.
to ask you think about why exactly the drink consumption. Is it really that useful to make such complex analysis for this topic?
I don't understand your question. 1 second, please.
Sorry, one more time. Why exactly did you choose the beer consumption? Is it really necessary to make such complex analysis for this topic?
Oh, the reason for beer consumption. Correct?
Yes,
Am I
yes.
correct? The reason for beer consumption.
Yes, this is a question.
Yes. One thing is it is not the independent data, so it is connecting with the health department. Okay, so because we know, because all we know, the health insurance are very important in the European countries. So it is based on the health, based on this data. They are. I mean, they are regulating the policies.
Okay, it's for the health. Okay.
Yes.
Okay, thank you very much. Now,
Okay.
yeah, please, we have a next speaker with a presentation with ID 19.
Yeah,
Let it
I'm
say-
going to.
Oh, you have a second presentation, right?
Yes.
Okay,
Yes.
now you can start your second presentation, and the next
Okay.
one after 19 we have presentation 24. Please be ready. I just want to remind you that time for presentation is 6 minutes and 1 minute
Okay.
for Q&A.
Okay. Is it visible?
Yeah, now it's visible. Yeah, you can start.
Okay. So my next topic is next paper is analyzing public perception of South Korea's low birth rate policies using NLP based sentiment analysis. Just a minute. Okay, so the purpose of this paper is it investigating the public sentiment on Korea's low birth rate policy using YouTube comments as the primary data source. Because now all we know, the YouTube is the big media, and then it is creating the big impact in the society. So the comments are very important because from the comments now we can analyze a lot, including the country security also. So now we are finding so many things from the social media comments. So but here we consider the YouTube commands only as a primary data. So we applied and compare various NLP models like naive-Bayes, logistic regression, SVM, LSTM, and BERT variants to analyze emotional tone and sentiment, and then we examine the effectiveness, pros and cons of different NLP models in emotion analysis, and then we explore the socio-economic implications of Korea's low birth rate through the lens of public opinion. We address the challenges such as data imbalance, complex language structures, and computational limitations, and then we provided the insights into policy implications, showing how public sentiment can inform or influence policy making, and then it's lay the foundation for future NLP based public policies. Then I mean it highlighted ethical consideration in using AI and NLP. Okay. And then the South Korea's low birth rate and policy response. Just briefly, I want to explain it. Then the South Korea's fertility rate has been below replacement level 2.1 for over 40 years. It reaching a record low of 0.78 in 2022. The government interventions since 2005 include the Basic Act on Low Fertility and Aging Society and 5-year strategic plans. They are implementing they are taking the efforts, they are implementing, they are offering some benefits like cash benefits, education, parental leave, and then but policies have not reversed the trend. And then the lack of support for working age parent, insufficient focus on youth, and over prioritization of elderly welfare. These are the, these are affecting their policy trend. And then the structural reforms in welfare, education, and employment are needed. The public sentiment analysis is essential for refining policy effectiveness. And then what is NLP? Natural language processing. So it enables interaction between the computers and human language. Then Korean NLP is complex due to the language unique morphology, because the Korean accent is different, their text is different. So because we will see how the bird is adaptable the Korean language by using NLP. And then 21st century Sejong Plan and Sejong Corpus were founded the Korean NLP. The key task means tokenization, stemming, lemmatization, NER, and sentiment analysis. So first, the data pre-processing is essential, and then the continuous advances in ML, machine learning, improve the NLP accuracy in Korean. So the sentiment analysis extracts subjective opinions from the text, example like positive, negative, or neutral, and then it used in various domains, including politics, culture, and media, and economics, education, health, everywhere. And then the basic methods, the vocabulary base is the basic method. It struggles with nuances like sarcasm. So advanced matter like BERT. What is BERT? Offers higher accuracy but require high computational resources. The challenges are language complexity, multilingual processing, and bias mitigation, and its growing use in public policy for real-time feedback and evaluation. So what is BERT? It's a bidirectional encoder. It's influence of YouTube. So the YouTube evolved into a major global media platform and its opinion shaping tool. So it projected to reach 1.1 billion users by 2028. So this is acting as a channel for public disclosure on policies and social issues, and it's also activism, education, and cultural exchange. And then it's an algorithm driven nature, amplifies key social concerns and valuable for monitoring public sentiment in policy making. And then the comparative study of NLP models. And then the deep learning models extract features directly from data. It's enhancing the NLP task. So the BERT revolutionized NLP with bidirectional context understanding, which means because the BERT naturally it understand the context of the text. Example like if we are using the same pronunciation means, so based on the sentence, the BERT will understand the context of the word. Example like we are using have means, so it's based on the sentence, it will understand whether it is the organ of the body or it's similar like a rabbit, animal, it's animal. So
Please.
yes, yeah. Okay, so the popular NLP models means logistic regression, SVM, naive-Bayes, LSTM, BERT. But here we specifically use two variants, CoBERT and KC-BERT. CoBERT is a Korean BERT, and then KC-BERT means Korean clean BERT. And then this is just comparative study of how the NLP models. The first one rule-based NLP. Next one is machine learning-based NLP. Another one is deep learning-based NLP model. And then this is the sentiment analysis model, the existing one, the logistic regression. But here we compared everything with CoBERT and KC, KO-BERT and KC-BERT. And then the logistic regression, it's a simple, and the SVM It's effective in identifying clear decision boundaries, good at detecting positive sentiment, but less sensitive to negativeness. Even the logistic
Okay,
regulation
thank
also.
you. Thank you very much for your presentation.
Okay.
It was very thoughtful. And yeah, very thank you to you. Now you can stop your sharing your screen
Okay.
and turn off your webcam. And we are giving 1 minute for Q&A. If we have any questions, yeah, please.
Yes.
Yeah, maybe it's invisible to you, but here we have full of auditorium. Here we
Okay.
have almost 40 students and
Okay.
professors sitting here,
Okay.
and we want to ask some questions, please.
Okay.
Today, I want
Yes.
today I want to ask a question about the key shortcomings listed. Beyond the key shortcomings listed, can data science analysis of public sentiment identify other significant, perhaps not obvious, factors or concerns that influence people's decisions about having kids in South Korea? What other key shortcomings can be?
I don't understand your question.
You can repeat it.
Beyond the key shortcomings listed, can data science analysis of public sentiment identify other significant but not obvious factors and issues that influence people's decisions about having kids?
Okay, here maybe maybe later our students will directly to you write their questions. Maybe they
Yes,
can
sure, please.
more details they respond. Thank you for
Yeah,
your
sure. Okay,
Yeah,
thank you.
time
Thank you
is
for this
short. Yeah, thank
opportunity.
you. Yeah.
Thank you. Thank you. Yes.
Upload your presentation for this chat.
Yeah, maybe you can send your presentation as a PDF file to this chat, maybe to the emails. Okay, our next presenter is with ID 24. Are you here? The first author is Gurlip Mindabayev. And the next our presenter is ID 28. Are you here? Okay. Then instead of ID 24, we can give a presentation for ID 99, right? Nina Kosheva. Yeah, please. 99.
Excuse me. Can I present ID 89?
Yeah, ID 89 would be after. Yeah, we will let you know.
Okay, thank you. Yeah, you can start, please.
Going one. Provide obviously technical organizers for writing us and accepting our papers. I work on this project with Professor John Mogan from We can't hear.
Can't hear you. Maybe you can stay close to the microphone.
The final of what is learning with for itself. Why? Why? Адлет, ничего не слышно. Такую запись потом не примут.
Когда встать? Вот. Ага, теперь.
Вас-то слышно, а вот докладчика нет.
Hello everyone, my name is Dina Kaisheva. I'm from Kazakh British Technical University. First of all, I want to say thank you for organizers for inviting us and accepting our papers. Our work is titled Deep Learning with Multi-Head Attention for Respiratory Sound Analysis. We work with Professor John Bonkan, Korean National University of Transportation, and Professor Arsen Mukasheva from Kazakh British Technical University. Why this study is important? Respiratory one of the leading colleges of illness worldwide, and the doctor usually uses stethoscope for identifying for more subjective and depends on experience, because there are different types of similar sounds and making diagnosis so difficult for doctors. And we try to explore how deep learning can help and automatically classify respiratory sounds for diagnosis. In this slide, we can see death rates in different types of countries from 2020 and 25, pneumonia and COVID-19 by region. And how it's working. Slides our data description and we are processing steps. We have downloaded open public data sets. It has 1,020 audio recordings from 5 classes: osmo, pneumonia, healthy, bronchitis, and COPD against chronic lung diseases. As we can see in picture 4, class distribution and class imbalance, and we augment some classes for improve this, and adding some Gaussian frequency, and now we have 2,400 samples. In picture 3, we can see original waveform and the spectrogram representation of the sound. And in picture 5, you can see original POV for example at the sample, and in a V as a accumulated bit noise. Our methodology have 3 models, seen in LCM. All 3 models we have for first layers is a convolution for first deep, but another after convolution for deep, we added model with additional LCM. We added by LCM. That self-attention, AX, Then, the attention mechanism operates through parallel competition on QK matrices and it's merged the input via residual connections. So our model of more attention and focuses on not only one point in several points in the sound and give the model more focusing and improve our accuracy. In picture 6, we can see pipeline of our methodology with audio and then optimization, extraction, feature extraction, and then evolution by William. Can see by now our model result. Then another one and validation accuracy and dynamics over watch can see the full one with attention. More accuracy than another and in figure 8 we can see this diagram. It visualize what model 3 how it explains our result. In Slovenian with the attention more have more focus. One comparison, the whole another. Our results on models video studies have almost like 40 or 90 for accuracy. And another we evaluate and compare 3 models. One data bidirectional subtexting and attention mechanisms, but our study also has limitation because it has limited data. In the future, we having more data and try to put in model performance. Also have limitation of station with the OPD and we're focusing on this issue.
Okay, thank you very much. Now we have 1 minute for Q&A. We have online participants and in person. Yeah, please. Let's start from.
Thank you for presentation. I have a question. How will this study improve our medicine in Kazakhstan?
This is very improved. In future, we want to data, but more data and some apps. But now
More question? Yeah.
I have a question.
Yes.
Thank you for your presentation. And my question is, why are you using attention and what is the...
So the one question is going on. After that, your question will be present. Okay.
Okay. Sorry.
Please be closer to microphone. We can't hear you. Please be close to microphone.
Okay, and we have one question from online participants. Yeah, please, you can start.
Thank you for your presentation. And my question is, why are you using attention, and what is the difference between multi-head attention?
We can't hear you. Sorry.
After BLSTM, in our model, we use attention after BLSTM. And attention, it's different with this attention difference with from multi-head or multi-head attention difference from attention. It means we are focusing not only one point on 3 points. Because sounds, it's a time to have not to have on.
Yeah,
Focusing on 3 points.
thank you for your response. So we have a little bit.
Okay, dear colleagues, for the next presentation, I would invite presentation with ID number 43. Javed Hussain, Nanjing
Can you hear me? Can you hear me?
Please turn your camera on.
You can proceed.
Okay.
Thank you.
Okay, thank you. You can start. You have 6 minutes for your presentation.
Okay, thank you. Share my PPT. Can you see my PPT?
Yeah.
Yes, you can see.
Okay, thank you. Let me 1 minute. Okay. This is Javed Hussain from Nanjing University of Information Science and Technology, Nanjing, China. So today I'm going to be presenting transplant learning assisted cervical cancer categorization from Pap smear images via the multi-head attention technique. So let me introduce what is actually cervical cancer. Cervical cancer basically one of the most prevalent and most occur recent years in cancer, one type of cancer. This is occurs basically in woman human body in cervical cell, this cervical cell basically situated in the uterus upper point. So this is basically occurs in human body. So what is the problem statement of my research? There are lots of existing work have been done recently based on this cervical cancer, and they using lots of techniques. So based on existing study, I have found some limitation, and I want to sort out and I want to solve this issue. That's why I will improve the in terms of accuracy, in terms of visualization, in terms of precision, and all of evaluation metrics and real life application to be evaluated more precisely than existing one. This is my challenge. So problem statement basically difficulty in extracting relevant features from complex Pap smear image. This is the most important thing. In Pap smear image, this contains a lot of informations in all of the inter images. So we need to find out each and every pixels. So which pixel is important things or not. Based on these conceptions, we can find out whether the patients affected by cervical cancer or not. Then number 2 is limited on generalization of written models. Recent researchers, they have used most of the 90% researchers, they have used MobileNet, VGG19, AlexNet, lots of written architectures. We find out some limitation from written model because of some limitation is there. Always travel to find out maximal accuracy by using their written layers in terms of specific reasons. overfitting, and they basically CN architecture, they treat each and every pixel as a same level. Like this, in central point, which cell actually affected by cervical cell, they treat same like this. Which cell is not affected by cervical cancer, they treat is the same level. So CNN focus on the same level and same significance each and every pixel. This is the main limitation of the, I think, for CNN model. Number 4 is focus on relevant image regions, stabilize model training, and balance computational efficiency and performance. I will discuss later. This is my overview of my proposed model. So you can see that first of all, we need to our data set. I though Kaggle, I download this data set by medical data set. This is input image of cervical cancer. There are 5 types of cervical cells, but we divided normal or abnormal, like this dyschorotic, cholecytic, and metaplastic. These 3 cells we converted, we consider as abnormal cell, and paravessel and superficial intermedia for we are considered for normal cell. That means 2 class, abnormal and normal. Abnormal contains 3 cells and normal contains 2 cells. After that, we have done image preprocessing. You can do is image augmentations, image resize, and proposed classification model. We can use customized model, mobile net architectures plus multi-layer attention mechanism. We have applied 4 similar architecture, but we got maximum accuracy when we applied custom ResNet 101v2 plus multi-layer attention. This is our fine-tuned model. So this is our, I already discussed, dyskeratotic, cholecytic, and metaplastic is red color. This we have considered as the abnormal. Abnormal, that means abnormal cell, and paravessel superficial is a normal cell. Some on patients contains this above dyschorotic, cholecytic, metaplastic. We can say this patients affected by the cervical sensor. Otherwise, paravessel and superficial intermediate, we can say this is secure. He is oil, or he or she is oil. He is or she is not affected by the cervical cancer cell. Okay. This is our training, testing, validations, and distribution. Then this is the sample of our data set. And this is our data augmentation part. You can see rotation with shift. And this is the multi-layer attention mechanism. In my recent presenter is already talk about this multi-layer attention mechanism. One presenter and one, I think, audience asked a question, what is the difference between attention and multi-layer attention mechanism? So I can more clear in these sections. Multi-layer attention mechanism means multiple attention mechanisms simultaneously through the apply the attention mechanism simultaneously. So here I applied like this is a multi-head. You can see this attention mechanism based on 3 parameters: query, key, and value. So you can this linearly we can say the multiple product. That's product multiplication between each and every simultaneously line, and it's gonna attention score, and finally they are. This is the multi-attention mechanism. This is only one line. One is how to say one determination or multiplication between query, key, and value. But when we applied multiple heads simultaneously, when you applied multiple attention mechanism, is called multi-head attention mechanism. In that case, for my research, I have applied multi-head. Number of head is 8. This is my visualization features map, and this is my contribution. I have applied extra multi-layer attention mechanism and brains layer. And here, why actually I applied multi-layer attention mechanism? Multi-layer attention mechanism basically find out important region from your pixel, from your from your images. So cervical cancer, like this paper images. Whole of the image not important for your research. Your important region is which region actually affected by the cervical cancer. So how do we get which cell actually affected by the cervical cancer? That means model find out which cell actually affected by cervical cancer by the importance of attention score. That's why we applied multi-head attention mechanism. This is our main contribution. And also I applied GLOS average pooling layer normalization. Layer normalization basically we have applied for the how to say, for the prevent the overfitting or underfitting problem. And also dense layer connected each and every layer connected each other for the not chance to lose the informations. That's why. And this is our we got optimal 93.41 accuracy, and this is.
Excuse me, can you proceed to conclusion part, because time limit is reached.
Okay, thank you.
Okay, then please leave the presentation open. do not close your presentation until the end of question answer session. Please, your questions. Come to microphone.
So, what techniques did you use to ensure stable training in your deep learning model?
Sorry, again.
What methodology?
Yeah, methodology.
Techniques used for stability of your model in training in the process of training the model, deep learning model.
Okay, I have used lots of several pre-trained architecture with customize the using extra global average spring layer, extra dense layer, and also multi-head attention mechanism using MobileNet V2, ResNet 101, ResNet 152, V2 version 3 several model. But I got optimal accuracy when I applied ResNet 101 V2 version model with adding extra dense layer, extra global average spring layer, and also extra multi-head attention mechanism, which gonna be help to find out optimal region from your images.
Thank you for your answer.
Thank
Another
you.
question? Okay, let's. Next question also you can come prepare. Finish.
Hello, Professor. So thank you for your presentation. I have one question. So your data set that you have been taken for your study, is it like open source and everybody can make a study?
Yes. This is available in Kaggle website. SpyMac dataset is available. Open source. Available in online.
Professor, one more question. Could you share your data set?
For research purposes, he asked if he can get such data set.
I will share. Okay, I share the link through this Zoom meeting. I will share this here. Zoom.
Thank you, Salam. Thank you very much. Another question. We have one more question. For the next questions,
Thank you for your presentation. I have a question. Before you showing some pap-smear images of cancer, and you also have given a text of image preprocessing, and I would like to know more details about classification of models that you gave after.
Okay, understood. Classification, basically we applied we collected in dataset basically contain 5 class: dyskeratotic, cholecytotic, and metaplastic. A board-free cell I consider is an abnormal cell. That means which patients contain these kinds of cell, then we call these patients affected by cervical cancer, and the rest of the 2 cell is paravasal and superficial intermedia. Which patients contain these 2 type of cells, then we call this patient not affected by cervical cancer. So we just collected 5 class, then we divided into 2 subclass, normal and abnormal. Our class is basically contain 2 cell. In dense layer contains 2 cell. Yes.
Thank you very much for your presentation. Let's shift to the next presentation. I would ask if it is ready, presentation ID 63. Aygerim Aytin from IIT University Kazakhstan will present.
So hello everyone, I am Jamila and I am here today with my teammate Aidana to present our paper titled Intelligent Line Detection with Machine Learning. So we represent International Information Technology University in Almaty. So before starting, I want to tell a short overview how we come with this idea. So a few months ago, we looked at live X-ray and thought if we could build a model that can see what doctors see and even more. And this idea became our project, using AI to develop more faster, more accurately, and more accessible Lyme disease detection. So here you can see overview what presentation will cover. So let's talk shortly a problem statement. As you see at the presentation, Lyme diseases like tuberculosis, lung cancer, and pneumonia are still a major global health problem. By this, apparently you can see that we need a solution that can accessible for everyone and for doctors and help and gives us a solution like a more faster, accurately to analyze and reduce human error. So the research objective of our paper is to build a machine learning system that can assist this analysis by using measurements. And the specific aim of our paper is first fine-tune and then test model for our own medical data. The next one, compare this model. We use metrics like F1 score and accuracy. And the next one, to achieve clinical interpretability, it means like use a grad scan for doctors for more framework. So let's all this latest work. Many studies show that machine learning has a big potential in Lyme disease detection, and DNA-based models outperform traditional ML methods. And some models combining CNN with the clinical data cause research shows enhanced diagnosis accuracy. So let's talk more about the first thing. So first of all, our data set is not too like real and not so big, and there's also we have a range of representing of this data. For example, we have sometimes in kernel data set some echo models, and also we also added our own data set. And next, data identification. Why it's necessary? Because this helps to protect our audacity, and especially given the limited size of the data set. For example, you can see that the data shape the answer how it like different. Because in our idea, it's not only about them, it's also part of our system. We have a for example, safe example in the solution and for preventing this kind of thing. So one how many see or widely for prepared base for medical imaging. So first of all, we last for the wireless unfrozen. But why we making this? Because first of all this wireless it can be over the applicant will need to ensure that it's gonna be like more accuracy, but not like remember all of this stuff, remember like or images or less images, and then we think that new images will be recognized. How to our model. Also achieve the balanced result. And if we talk about fun, we want to extend our database and make a collaboration with local clinics, with hospitals, and also combine experience with not only experience, but also with clinical data and with lab results. And also we now we develop medical application and web platform, and in future we plan to launch this platform and can use it.
About our condition, like what kind of thing we need to do.
Okay, thank you. Questions, please? Come to microphone. And second question also. You ready? First question, please. Microphone.
So thank you for the presentation. I have a question. What kind of data do you use for teach AI to understand where is, for example, tuberculosis or pneumonia?
One only aims because first of all it's making like 5 classes to have practical, and after that all of these 5 classes learn and the one about, and because of that machine learning can actually answer one plus one after that, and after that give a conclusion like one of these part has some characteristics, and after that we can excited each class.
Next question, please.
So my question is, did you compare prediction of this technology with the predictions of real doctors?
Yes, we also need this one because when people will find that someone who also have this kind of things, and after that we also will help to test one this way doctor situation or something like that, and then we have only 10 or 20 this figure how this and the our condition is equal or not.
Yeah.
So,
Who was like more accurate?
more accurate, how I can see more accurate because we like for our doctor. Available, but we have a lot of one of them was the same.
Last question, okay? Так, а вот девочка. When what? Main difficult in? Huh? Okay. The question was about what difficulties you consider as the main difficulty in your research, yeah?
Model. And then said adaptive treatment, and after that, we always after
Бір тағы бір последний вопрос. Last question. Так. Айта бер, отырып айта беріңіз. The question was, I think, about how, if you have these results, how they can be used for real situation, for real cases, for treatment of disease.
First of all, our
Please close to microphone. We can't hear you.
First of all, the doctor also can see, and you can see which kind of you have a disease, and after that, all of this collected, and they give yes, conclusion.
Report.
Report.
Yeah,
Something
we
like
can
report.
give report from our platform, and that if this one doctor gives the result of my
Doctor in real situation can use as supporting information.
We also want to show that new technology can also approve doctors' works.
Okay, thank you very much. You can skip to take a seat, please. For the next presentation, we consider presentation ID 89. 89.
Yes, I'm here.
Bakhtarzad Abdurrahmanov.
Yes, I'm here.
Yes.
Okay, let me
Okay, then you can proceed.
prepare 1 minute, please. Okay. Can you see this?
Hybrid AI-based static
Yes, we can
analysis. Yeah,
Okay.
you can see.
Okay. Good afternoon for everyone. My name is Bagdolet Abdrahmanov, and I'm representing Astana IT University. Today, I will present my research titled Hybrid AI-based static
Can
analysis.
you turn on your camera as well?
I turn it on. You can see it.
Yes, we can.
Yes,
see
yes, yes.
you.
Oh, okay. Okay. I will present my research titled. You can see this in presentation. Okay. Next. Why are we still working on malware classification? Despite the presence of antivirus software, intrusion detection systems, and full stack security, modern malware continues to evolve and bypass traditional defenses. We still see major attacks every year, including the ransomwares and the fileless malware. This motivates us to look for smarter AI-driven solutions to detect malicious files more accurately and efficiently. Okay, next. The goal of my research is to develop a system that can classify files as benign or malicious based solely on static metadata. This approach uses machine learning and explainable AI techniques and focuses on both high accuracy and interpretability, which is crucial for security operations. Okay, next. Today's cyber threats are more sophisticated than ever. Attackers use obfuscation, encryption, and even artificial intelligence to make malware invisible to conventional scanners. As a result, relying on traditional tools is no longer sufficient. We need proactive and data-driven methods. Okay, next. Here you can see that this dataset includes 18,000 Windows PE files. Here, 10,000 malicious and 1,000 is benign, collected from open source repositories and verified manually. This imbalance reflects real-world scenarios where files are often rare. Only static features were extracted, no execution or sandbox was used. And also here for initial training and testing purposes, balanced subsets of 2,164 files used to validate the methodology before scaling. Okay, next. Okay, next. Traditionally, malware analysis includes static and dynamic methods. Here you can see the 4 columns. First and third columns are methodology of the static analysis. First, it's a basic, and the third column, it's advanced static analysis methods. In this project, we can focus on static analysis, which is faster and safer, and we explore how AI can automate these processes. Okay, list of features collected. I extracted a wide range of features, including the general properties like file size, entropy, timestamps, p-structure data, sections, compiler version, entry point, and imported DLLs and functions, byte frequency statics, and even additionally various total verdicts via hash checking. It's to fulfill the prediction. This gives a rich feature space for training machine learning models. Okay, next. Okay, here are the machine learning methods. I trained, tested multiple ML models, random forest, decision tree, k-means, native bias, CVM, and boosting models like extreme and light gradient boosting, deep learning, MLP using Keras, and I think it's the main point of this research. It's a stacking ensemble, combining the top 3 by the accuracy here methods. This wide range allowed us to compare their strengths and in static malware detection. Okay. Okay. To make methods explainable, I used SHAP. It's a Shapley additive explanation. SHAP helps us see which features had the greatest impact on classification, like file size or entropy or Cartesian DLL imports. It also helps us reduce the feature space by removing low impact features. Okay, evolution methods. Here I applied stratified k-fold cross-validation for fair training. Hyperparameters were optimized using grid search CV and Optane. As evaluation metrics, I used accuracy, F1 score, and confusion matrix to check the both balance and precision. Okay, here selecting and configuring hyperparameters. Each model.
Conclusion.
Yes.
Conclusion. Conclusion, yeah, because.
Okay. Here you can see the key results. Okay. In conclusion, this system achieved the high accuracy using only static metadata. It's 97% accuracy. It's explainable thanks to SHAP system, and it's optimized for real-world class imbalance. However, it has limitations. Static analysis alone may miss dynamic behavior or obfuscated payloads. Future works included that will be their integrated dynamic analysis, sandboxes, system calls tracing, expanding the data sets exactly, and developing the hybrid models for even better detection. That's
okay.
all.
Thank you, Bogdanet. I have one question.
Yes.
About you have applied so many, about 10 models, machine learning models for your research, yeah? And then came to conclusion about that best model is stacking ensemble. And according
yes.
to which evaluation model or which evaluation parameter or metrics you can highlight, which gives you such conclusion, yeah?
Okay, let me return for this slide. Here you can see that here in key results, you can see that the best results came from random forest, light gradient boosting, and the extreme gradient boosting methods. Here and the stacking ensemble method gets all of these models which was trained, and sends their results for meta model, which training by their results, and achieved this kind of accuracy. CVM and native bias performed worse, showing that ensemble method work best in this domain. And the ensemble method.
Okay, Bagdoli, thank you very much.
Okay.
Another question, please.
First of all, for presentation, so very interesting speech, I think. So my question is, what improvements can be made to improve the performance of the static analysis?
What improvements? Okay. Maybe for this project, maybe that's only to take best hyperparameters for these all models and expand the data sets. I think for these projects, it's only way for now. And exactly making the hybrid model, which conclude that covers static and dynamic analysis, because it's crucial.
Thank you. Any other questions? Yeah, please.
For your presentation, I have a question. You have shown a variety of analysis models, and I have a question: which one is exactly the worst, and would you exclude this model in your future researches? Why?
Yes, here the CVM and the native bias performed worse, and I think that's will make the more optimize. It will more optimize during the training this model, and I think yes, a native bias will be excluded in this project.
Okay, thank you. Do you want to ask? Yeah, please.
My question is, for example, I'm a criminal and I made a malware program to affect exactly to your model, and how your model is gonna defend himself.
How what?
Maybe how your model is defending himself. Or maybe you trained it for this type of cases.
This model's goal is for classifying the files which the SOC analytics security operational centers, which gets for example the files by EDR or CM systems or another sources, and there needs to make a quick static analysis, and this model is not architecture that for defending himself, and it's not there's no reason for attack or something else for this trained model, I think.
Okay, thank you. So yeah, thank you for your presentation.
Okay.
Now we can stop the sharing.
Okay.
So our next speaker is with ID 92, right? Yeah, also from Astana IT University. Yeah, let me open. Yeah, please stand closer to the microphone. Thank you. Yeah, you can start, please.
Hello, everyone. My name is Pavel Soy. Today I'm going to present my article about overviewing of existing machine learning algorithms in healthcare system and its implementation in Kazakhstan. So let's start with introduction and with the healthcare challenges that we have. As you know, the Kazakhstan does not have any widely used machine learning approaches in medicine sector, and actually most medical systems are not digitalized properly, so we could easily integrate it. However, implementing ML algorithms and let's see, for example, CNN networks may significantly improve the accuracy in working with medical images, and for example, respiratory disease, and also it will help to save doctors and medical staff time that they spend on analyzing these medical images. And what about the novelty and the purpose of the study? So, as you know, medical images are mostly relevant with CNN models and vision transformers. The main goal of my study was to investigate and research the main methodologies and main methods that I used working with such kind of images, and identify what are the most efficient approaches here. So let's talk about the lecture review. You know, global ML advances. Actually, we don't have models that operate with high amounts of medical diseases at once. For example, most models are just focused on a small amount of classifications, for example, 2, 3, or even a single disease, and this because the problem of when you have a lot of disease classification, it creates additional troubles with model training and result validation and so on. So the accuracy, the more classes you have, the less accuracy you receive in the output. Yeah. So in the Kazakhstani context, as I've already said, there are no widely used ML models and no integrated neural networks in the hospitals, government hospitals. So let's talk about the disease-specific models and the challenges that we face. So first of all, we must, when selecting the dataset, we must ensure that it has expert annotations and proper markings for proper accuracy. Also, we must rely on standardized terminologies, for example, with P. And about the implementation challenges, as you may know, images require special equipment, for example, the GPUs itself, and regular GPUs that we use, for example, in our PC are not suitable here, and it requires particular GPUs, for example, A100 models, and so on, and they're not so cheap, and hosting server with such GPUs requires strong financial support. So let's look at the dataset selection. So here you can see the I used CNN formats and hybrid approaches here in my experimental setup, and 2 large datasets, and G-Expert and G-X-Ray. So let's talk about reprocessing and transfer learning that I use actually in my work. The preprocessing steps firstly includes resizing and data normalization, and besides we also, since I'm going to create something like a mobile app or web application that will be easy to use for like regular users. I also added noise and images augmentation. Added, for example, rotations, shape shifting, and brightness changes to make, because in these datasets, we actually working with like ideal conditions where the images are like of high quality and so on. But in real situation, it will not be like so ideal. So here you can see the experimental results that I have. Actually, one of the previous participants also shown like a similar topic, and they had about 67% accuracy. And actually, in the beginning of my work, I also had faced like some troubles with model training. It was connected to like data preprocessing and like validation techniques that I used first time, but so here you can see the experimental steps and metric that has shown that CNN and particularly DensNet's model has is the most relevant in my case. And this is also the confusion logic that shows how effective the model actually is, and that it can be used for like further fine-tuning. So in the conclusion, I can say that comparing several approaches and several models, I found out that it's better to use CNN-based approach, and that we already said in further directions, I will focus on mobile development, for example, to make my model like widespread and for regular users. So.
Okay. Thank you very much. So now let's keep for Q&A online. Do we have any questions? Yeah, please.
So my question is, do you have in mind to create your own data set rather than using it from the open source? Actually, what do you mean about creating my own data set? For example, use some local data sets from our project values. Maybe in the future, if I will consider some integration with hospitals, then it's probably possible, but still it's kind of hard because it's all about like data privacy and all these aspects must be taken into account. So, and generally, locally collected data sets may be like may include not so wide range of classification, because it's hard to like mark all these images with proper like diseases, and so I think it's much better to like train and validate the model on the open source datasets that are already include more than 200,000 images.
Okay, thank you. And we have one more question. Did you finish your question? Yeah. Okay, we have one more question. Yeah, please.
My question is, you say that nowadays we need efficient GPUs such as NVIDIA A100 and NVIDIA 6000. But nowadays we have AI box GPUs with NPU box such as the i9 275 HE, like that. Can we use AI box GPUs to change GPU dependency?
It's used like Sandra Course processing. Can you provide like some example?
Давайте, ребята, во время кофе-брейка дальше.
Generally, I mentioned this model of GPU because it's hard to say if we can replace it with your suggestion because for working with CNN models and images, all we need a lot of like virtual access memory volume. For example, in NVIDIA 100, we have like 40 gigabytes of RAM, and it also has specified like architectural type with a lot of tensor cores included in it. And so I don't know if it will be like more efficient to use your solution. And generally, I didn't see like such comparisons here. But as far as I know, this type of GPUs are most efficient in benchmarks and in this.
Okay, thank you very much. Thank you. Thank you for your question. So yeah, we have finished, right? Okay. Thank you. Our next speaker is with IT 100. Gina Oshiba. Yeah, please. Yeah. Yeah, no, yeah, okay, you can just, yeah, speak a little bit louder.
Okay, hello everyone. My name is Zina Kashiva. My research title is analysis of PG signals for public BioMTM. Our research focusing on how with AG data we can how with AG data around the world, and it that people with Parkinson's disease have problem with movements, memories, and some memory. We can try with AG, how with AG and learning we can find this different with Parkinson and not Parkinson. Open source data downloaded from PCONet. It's from Parkinson one technology also with with delta, theta, alpha, beta, and gamma from AG. So, for example, G data not static, type you can teach break down our models and results with methods, results higher accuracy than previous results. Our model achieve higher accuracy. So, break down now the transforming also spectral analysis and to find our data and try to make them so
Okay, thank you. Thank you for your presentation. Yeah, let's have a question and yeah. Yeah, could you come closer? Yeah, because here we have a microphone.
I have a question about the accuracy of your research. And my question is, what steps would you take to improve the accuracy of your chosen model further?
Maybe we put some type data and some aggregation methods. Sure, it's so difficult to find out this types of data because it's Parkinson and
Okay, we have a second question. Thank you for your question. We have a second question online. It says that why did you use spectrograms instead of raw signals?
Because spectrals signals give us more patterns and give models more patterns than raw data, because raw data, as you can see in the first picture, is just a signal, and when we transform this into spectrogram and model see this as a picture. So,
I'm sorry, could you hear the answer? Yes, could you hear our response? Oh, okay. Yes, okay. Do we have any other questions? Okay, guys, professors, dear students, our first part of our section is over. Then now we can have our coffee break, and the second part we're going to start at 4:20 p.m.
With the presentation ID 100.
Yeah, with the presentation. Yeah. Dear online participants, we are going to start at 4:20 p.m.
Бахчан, остановите. Камера Камера.
Человека камера? Или...
Нет.
Да.
Наша камера не показывается вот этот из демонстрации. А вот а вас не сделали.
Dear participants, hello. So let's start our section number 4, data science and advanced analytics.
So the next presenter.
So presenter will be Abdul Karim Bakhjan in Astana IT University and Dinara Khaybasova, Astana IT University.
Please speak closer to microphone so our online participants.
So our topic is face recognition system, professional VS for cyber software based on the convolutional neural networks. So we're going to the outline, here the key points of our presentation. So we are moving to the introduction part. In introduction, I want to say that in many fields except of cybersport, the CNN was with a wide range, with the popular and using in all like Face ID systems and so on. And in eSport, it will help us to ensure like player verification, fair play, and event security. And in objective, the main goal is to develop a CNN-based system for identifying professional esports players. Moving to the dataset collection, it is one of the most time-consuming parts of our research. For the sources, there was two main sources. First, tournament recordings. Second is the interviews, social medias, and the official team pages. From this table, you can see the images count of 5 classes, like the 5 players who know the cybersport. I think they know these nicknames. And these images are raw, like not pre-processed and so on. In the data cleaning and the pre-processing part, as you can see, firstly, with the raw images, I have the manual cleaning. So like the duplicate images or some images with no eyes and maybe with some noises and with low quality images and so on. Face detection, for the face detection, I have used the hard cascade. It uses these algorithms, the pseudocodes that I provided in the presentation. You can see from here, 9 steps and the continued, in total 18 steps. Firstly, it is like my manually cropped image of pro player. Second one, it is the hard cascade used in this image. It draws like rectangles on the face and in the eyes. And after that one, it crops the image, so it will be like the more clean than this one. And after that, that's like methods. I have stored these images in the data set. The sample is like 5 classes with the 5 layers, and then here the table that concludes our data set after pre-processing. So here like almost 200 for 5 layers, it's like 1,000. And I have split it by 50 by 50 in train validation. In the model architecture, as you know, I have used the CNN with the 4 convolutional layers and the format toolings with the flatten and the dense layer, and then in the output layer, like how many classes are in the classification. You can see here around the output shapes also like the use. I have used some resizing the image to 148 and some data augmentations and so on. In the training and the prediction results, I have two metrics. Main metrics is the accuracy and the loss. In the accuracy, as you can see, I have trained 100 epochs with 64 batch size and the learning rate 0.01. Yeah. So after that one, you can see that the accuracy was nearly 85% for the training and 81 for validation. And the loss was like 0.5. It's quite big, and this is one of the limitations of my research. For the training, it's also it is for prediction results. You can see the pseudocode that I used for predicting some images in the application that I created for demonstration purposes. And here I have like the webcam on my laptop and like some players. You can see the rectangle and the label that are classified. In the conclusion, I can say that in terms of the overfitting, there was no overfitting, but in the limitations, the first and the main limitation was the data set size. It is the quite little, and I need to collect it in the future also. And also effective use hard cascade for data preprocessing and also for demonstration purposes. And it is suitable for real-time export deployment, but I need to work on it more harder in the future. And it supports the export integrity and the CNN module. Also, I want to mention that achieved 85% of accuracy. So I also want to expand the player size to not 5 only, maybe like 20, 30, and after that one is 100, 200, and so on. Because there was the problem with the data set. The data set is not exist in the open source. So thank you. You can ask questions.
Okay, thank you, everyone. If we have any questions, yeah, please, you're welcome. Please come to the
question. Hi.
Oh, yeah, we have an online question. Please, yeah, we are hearing you.
Yeah, why did you exactly choose this pipeline of training? I mean, there are a lot of state-of-the-art methods like ArcFace. Why didn't you deep dive into this branch?
Like the branch with the CNN, right?
I mean, have you heard about ArcFace loss?
No.
Okay. Okay, for the future, I suggest you to look for the ArcFace. It's the state-of-the-art method. You can look for inside Face GitHub repository, and you can find a lot in there.
Okay, thank you for your valuable suggestion. And do we have any other questions? Okay, if we have no questions, thank you for your presentation. And our next speaker is with ID 111, Batır Sharimbayev from Süleyman Demirel University.
And the Shravya.
Yeah, please stand closer to the, yeah.
If like weapons for requirement of IEEE,
Yeah, thank you.
should
Yeah, okay. Hello everyone. My name is Batır, and I am second year master's student at this university, major on mathematics and statistics. Today, it's my pleasure to present my research on text classification for AI-generated content. Today we talk about how to detect in AI-generated texts with machine learning and deep learning models. So why this work matters, challenges. Nowadays, AI models like GPT, Gemini, Grok, and Llama generate text that looks human-like. Here we know the three big problems First one is academic integrity. Students can use AI for their homework and their papers. Second one is fake news. AI models may write, AI models may generate text that is not true. And the third one is content moderation difficulties. That's why it's hard to tell AI from human writing. And we need to automatic detection methods. Here we can see some relevant works. First, through papers, use BERT to binary classification and received 97 on 71 and 93% accuracy respectively. And third paper authors use LSTM plus transformer plus CNN for binary classification also, and they received 99% accuracy. But all of the authors do only binary classification. Like text written by AI model or human. Here you can see our research objectives. First one is to classify text into 5 categories: human writing or generated by one or AI model. Typically, 3 or 5 rules appear or Da Vinci. Second objective is perform binary classification distinguish between AI generated and human writing text. We used over 200,000 samples total from conference on linguistics 2025 workshop NGT detection task 1. And here we can see the size of samples for each task. And we do proper testing, with lower casing, digit equation, and localization, and split into train and the test sets. Here we use 3 powerful models. Logistic regression for a machine learning model is TF, IDF, and bidirectional LSTM for a deep learning model is 489,000 parameters. And the T-Silbert is smaller, but faster and powerful model of BERT. And we find it only last 2 layers. Here we can see the result of multi-class classification results. Logistic regression gave us 81% accuracy. T-Silbert gave us 87 or 61%, and bidirectional LSTM gave us best 90% accuracy. And bidirectional LSTM showed highest accuracy on Bloom's models with 95 to 7%, and showed lowest accuracy on Kapir texts with 83 or 58%. And for binary classification, by bidirectional LSTM was 95%, and yeah, okay, we can see it, and the right one is confusion matrix for binary classification. In conclusion, in the future directions, all of these models by bidirectional LSTM outperforms other models for AI generated text or content for content detection tasks. And the challenges are changing AI text styles and identifying humanized text. In the future, we want to create the model that resistance to humanized text. Yeah, that's all. Thank you for your attention.
Okay, thank you for your presentation. It is very valuable. And let's have a Q&A. Do we have any questions?
Yes, I have a question. What is the most popular pattern when you detect when AI generates?
Yeah. here a lot of patterns for detecting AI generated content. One of these is when AI model generate text, it always use optimal words, and the base words for generating sentence. And humans know. Humans we use words maybe, yeah.
Thank you.
Humans
So the second question is, you remove punctuation, but is for me it's very important feature because AI and human use different patterns to exploit punctuation. So can you explain your choice to remove punctuation?
I didn't know about it. Yeah, in the future I consider this is information. Yeah, thank you.
Questions, please.
I have a question. Could you go back to your data set information? Yeah, here. What do you mean by samples here? What is
In the workshop had I think more than 700,000 texts. We got only 200 over 200,000 texts for AI generated model content.
What do you mean by text? Is it words or sentence or what? Or tokens or what?
Just text rows. Like they have text, AI model, and AI or human.
Okay, thank you.
Thank you for your questions. Oh, please, yeah, we have one more question. One and last.
In the future, we want to use other powerful but more large data-based models like Roberta, Tiberta. Currently, Tiberta is state of art for binary classification. Yeah, in future, we want to use them. Thank you.
Okay, thank you very much. Thank you for your presentation. Yeah, let's have next our speaker, who is with ID 120. I'm sorry, 116.
Yeah. Can you see me?
Yeah. Hello, Mr. Sundar. Do you want to share your screen or do we need to open our presentation?
Can I share the screen? Yeah.
Okay.
Can you see?
Please give us a minute. Yeah, we can see.
Okay, good. So good afternoon, everyone. So I would like to present my work called Intelligent Urban Greening Assessment using Machine Learning and Aerial Imaging. So this work was made up from the project called Smart City. So one of the part of this issue was to identify how green the citizens in our life in some big cities like Almaty or Astana. So the question to answer was like, why green spaces matter in cities? I think answer is quite easy. Because we can breathe better, because we can feel better. There will be no problems with health. So this kind of problems was to solve while I'm doing this research. Here is some small information from some other researchers why there was a lot of problems and how to solve. I'm trying to find some answer. Can we go to the next slide?
Oh.
Oh, sorry, I forgot. I'm sorry. So I was searching for papers. I found almost 20 papers and
Sorry,
even more.
we cannot see your second page or third whenever you are rolling it.
Can you see now?
No. We can only see the first page. We can only see your, what is that? Yeah, now we can see it. Yeah, now it's good. Perfect. Thank you.
So I'm changing. Can you see this page?
No.
Oh, should I do it? Maybe I can.
Now it works.
But it's too small. Maybe you can share that presentation.
Okay, yeah. Then you need to stop sharing the screen, and we're going to open the presentation. Yeah, we're going to the next page, third page, right?
Yeah, here. Thank you. Sorry for that technical problems.
You can continue.
So these are I collected all the researches into this literature review. So while I was searching some information how to solve that problems, I was trying to find out some ideas of segmentation, so I can detect some green plants and identify if much more segmented green plants I can identify, so it will be better for answering for green plants has most in some areas. Also, I was searching for detection, some trees, different flowers, even different objects I was trying to find out. And according to these researchers, I found the best for me, the method, that it was YOLO. So the model YOLO, the last version was 8. It was like modified to the last 11th one. So I decided to use the last model, and it was pretty good. So it gives me a 98 accuracy, and it was like for me the best choice of using it. The other methods was also quite good, but I just choose few of them. But by using of only YOLO, I decided to practice them. Okay, can we move to next? Thank you. So some experimental results that I have done is by using this method YOLO, I figure out so automatically detection and measure green zones in images. So images I was taking from the satellites, and also I was using data from RoboFlow platform. There was quite good, a lot of pictures that was helpful. And I also tried to use pictures from my own, but it was not much. So in total, when I was collecting all of this data, I tried to segment some green plants, trees, and so identified on some pictures. Even later, I was finding there during the videos, so it can detect also the position of trees. So, but it was the next part of the work. For this paper, I was only using the detection through the pictures. Okay, here are this is the study demonstrates how advanced computer vision techniques, particularly our method, enchased with the attention mechanisms integrated with the OpenCV TensorFlow, can revolutionize the environmental monitoring for the urban greening. So in the pictures, you can see how it was detected segmentation, and but unfortunately, we can detect only from the top of the view.
1 minute left.
Sorry. So we have to also to take a pictures of different angles, even if you're looking to the front, but it will give you different wrong accurate percentages But for this research, I only use the top of the view. So, but it gives me very good answer, almost 98% of this research. So, according to this work, I found a lot of things to work with. So later I would like to find the location of these trees and put them everything into the map and try to represent how it is working in whole, for example, botanical garden in the Astana. And by this work, we can show that for the even big cities, by using this small area, we can predict how green our area is according to this small research. So this is the most used, I think, in Astana, Almaty, and also for the big cities like Shymkent.
Okay, thank you very much. It is, our time is short, so we have a Q&A section. So do we have any questions for our speaker? Any questions?
I have one question. Thank you for your presentation. What species you plan to recognize in your future work? What kind of plant species?
So I just told about, I'm planning to represent everything in one area by detecting their trees according to their geolocations. That's my future work. And also I was doing a lot of issues at the same time, but according to this paper, only I'm presenting the segmentations. And I also found the detections. I also found their like percentage of how green is that. So I have a lot of work to do with.
So you said that the goal is to enhance generalization and refining plant species classification. So I'm curious what type of species you plan to classify.
So you are curious of what? Can you repeat, please? Sorry.
What type of plant species you plan to classify?
You according to classification method, you mean segmentation? I'm using segmentation.
What kind, in the future, what kind of plants do you want to classify?
The types, all of the types that in our cities we have. So if there are plants, I will be using that. So I cannot. I will name in the future each plants. Maybe it is the next level questions, but for now, detecting and identifying that names of the trees that our city has for now.
So you need a large volume of species images for this, because we have a lot of species in our city. Yeah. Thank you very much.
Main question is to identify how green is. Maybe it was the next problem, yeah, but I'm thinking about that. Thank you.
So one more question is, so as you are planning to implement your project into several cities, is it possible to optimize one general algorithm for all of them?
Yeah, it's possible, yeah.
Okay, if we have, for example, some properties of the cities or locals, is it possible to identify them by one algorithm?
So I identified, so I was using one method that I prefer.
Okay.
Thank you very much.
Okay, thank you for your presentation.
Thank you too.
Okay, next our speaker is with ID 121. Gulzat, the first author. Are you here?
Hello, can you hear me? I'm the second author here from this paper.
Oh, okay. Okay, could you share your screen, please?
Okay, just give me a minute. Can you see it?
Yes, no, not yet.
You cannot see it?
Yeah, now we can see your presentation.
Okay.
You can start.
So, yeah. Thank you for giving me the opportunity to present. I am Rahim Ahmed Rubo, and I have my co-authors Gulzat Turken and some other co-authors. So as you can see, the title of my article is Enhancing Query Classification in Chatbot Using LSTM. So I'm working on that section 4, and we are representing Al Farabi Kazakh National University. So as my paper is about this thing, so I want to first say about the challenges, like what type of challenges we are trying to solve by this paper. Here we have specifically there are a lot of, but if we specifically say handling varied and similar customer queries and like accurate classifications. And for this challenge, like what we considered mostly, we considered LSTM, and you may ask, oh, what's the reason of choosing LSTM advantages? There are like 4 things we considered till now. Like it captures sequential text patterns, it highlights key phrases, it has real-time
I'm sorry,
applications, and
Rakim. I'm sorry. We can see only the first page of your presentation.
you can see only first page.
Yeah.
Okay, I don't know what. Okay, let me fix it. I stopped it. Let's try it again.
Yeah, maybe you need to share entire screen.
Okay, let's do it. Wait a second. I will share the entire screen now.
We will.
Can you see it right now?
No, we cannot see you.
Yeah.
Oh.
It's still not working. I shared the whole screen.
No, give us a second. Oh. Now we can see you. Could you like move to the other pages?
Yeah. Should I go like this way?
Oh yeah, now it works. Now it works. Yeah, perfect. Thank you.
Thank you. Okay, thank you. So yeah, so as I was first talking about the challenges here for the customer queries and accurate classifications, and we have then advantages why we choose this LSTM. And as I already told about it, let's consider the next slides. It's the F1 score, the reasons just to come to this point. So yeah, so what's the aim of our study? It's like we want something accurate and which is more efficient in query classification in cleaning services. So by this paper, what how we contributed or what we did like we have focused on bidirectional LSTM model, and in this model after implementing we found success by F1 score 92.6%, and the others things were also like all we will explore it at the last part, how we find out that ours one is best because we used with CNN and others, but we found the LSTM's results are far better than that. So next, move to the next slide. Yeah, in the next slide we would say about the methodology, how we did it and what we did it. So here we had like data collection and pre-processing, and here we can see that we considered 45,000 user queries, and Queries included problem description and required services. And for the data cleaning, it's like remove 10% of irrelevant and duplicate queries. In terms of queries, as we are working with the queries, it works with this. And for the manual labeling, each query was manually categorized by a specialist. And in text processing, utilize tools like we use some kinds of tools for the processing like Spacey, NLTK, FastText. Okay, if we move to the next slide, we will see the like model training and architecture. So am I audible? Can you hear me properly?
Yeah, we can hear you.
Okay. Thank you. So in this slide, we have this model training and architecture, like model selection. As we selected LSTM, we choose it because of its efficiency in processing and sequential text. And we also tried some BERT, but it was not like that much considered because LSTM was more efficient in this work. So in this model architecture, we have like 256 neurons to capture context before and after each word. And in this, there is another highlighted text that calls attention mechanism that highlights keywords in the query for better classifications. And we have it classifies queries into like 10 service categories. So yeah, now we come to the like model evaluation and results. Here we would see the results of our mathematical terms, and also we would see the comparison. Here we can see that like at first precision we achieved 93.4% precision. Recall is also quite good enough, 91.8%. And like for F1 score, it is 92.6%. It is like a balanced one. And UCR that shows that it's accurate model. So here, as at the left of the picture, we can see that we have a comparison chart, which is like with LSTM, we compared the work the same with SVM and CNN. So we can see that first for the query length word, we can see first we work with 50 words, 100 and like more than 100, but it changes according to the word length, but it's not that much. We can see that always LSTM is higher in a lot of aspects. Like as we use SVM, CNN, they were quite lower than this one. So this is here, like we have these implications, like why this paper and what we are going to achieve with it. So here we used it for enhanced query classification. It is like cost-effective solutions. Why cost-effective solution? Because you may ask that now we have existing GPT and other things like that. But yeah, it's more feasible because the main thing is it has the privacy. And in GPT, it's not when we talk about GPT, it has some security issues also. But yeah, and if we talk about like broader implications, this one is like it has better precision and domain understanding, so we can use it for potentially for various industries and highly specific query types. So we have, as we work, we also have some limitations, and also we are considering some future works. So in terms of limited works, this model was trained on only 45,000 queries, which may not cover all possible user scenarios, limiting its ability to handle edge cases. The accuracy of the model depends on the quality of manual labeling, which can introduce human errors or bias also. For future works, we want to expand training dataset, data augmentation, fine-tuning for more categories, refining the model for addition categories, and we also integrate our systems with like booking, scheduling, and some other segmentations also. So thank you so much. Like this is the end. If you have any kinds of question, you may ask.
Okay, thank you, Rakim, for your presentation. So let's have Q&A. We have any questions? Please come to here to speak to the microphone, please.
So
So thank you for your presentation. I have a question. Did you use any pre-processing how can I say model?
Yeah, you mean
techniques.
we tried with BERT model, but it didn't give us like specific like
I mean techniques.
Yeah.
To improve
Yes.
your STME performance on query classification.
Yeah. So like here as like pre-trained model, we used BERT, but it was not efficient for us. That's it.
Okay, thank you for your question, answer.
Thank you so much also.
Do we have any other questions, please? Yeah, please. Could you come to here? Okay.
Mic.
Hello.
What are the main challenges faced when training a model with limited data, and how can they be mitigated?
Okay, I stopped sharing the screen just to because okay. Can you please repeat the question again? I couldn't hear it properly.
What are the main challenges faced when training a model with limited data, and how can they be mitigated?
Okay, so the challenges faced in it, like as we see, nowadays we can use synthetic and non-synthetic data. In terms of synthetic data, they are like adjustable, but as we use non-synthetic also, we use some kinds of things. So the challenges we faced while collecting a lot of data is like from one place we didn't find a lot of things. Like there were some things that we used to let me see the screen a bit. Wait a second. Yeah, here we used this SPACY, NLTK, fast text. These things we had to use, and yeah, I think if we can utilize this GPT, we also can we have future plans to use this GPT for initializing more samples or like using machine learning models. Also, we want to improve it in terms of synthetic, but in terms of non-synthetic, we have to collect from here and there. That's the problems, I think.
Okay, thank you. Thank you for your presentation. Yeah, let's have our next speaker. Okay. The next speaker is with ID 134 from Kyiv National University of Construction and Architecture.
Hello.
Hello. Could you share your screen, please? Yeah.
Do you see the screen?
Yeah, now we can see your screen.
Hello everyone, I want to show you my presentation about optimization of transport traffic in a network of medium complexity using deep learning with reinforcement. Introduction. Modern cities have evolved into complex transport hubs with roads, trams, and metro lines, creating major traffic management challenges. To address these, tools like traffic signals and systematic transit planning are used. Traffic lights typically operate in two modes: fixed programs with preset light duration regardless of actual traffic, and activated systems that adjust based on local sensor data. However, sensor-based lights often lack coordination across intersections, reducing their effectiveness in dense urban areas. Additionally, most systems do not leverage comprehensive site-wide traffic data, limiting the potential for intelligent adaptive traffic control. Literature review. Machine learning offers significant potential for optimizing traffic control system based on real-time traffic conditions. Various approaches have been explored, including the green light district simulator and methods like fuzzy logic and multi-agent systems. However, they typically focus on isolated intersections and do not fully leverage citywide traffic data. An effective alternative is deep reinforcement learning.
DeepQ networks, a prominent example, demonstrated success in games like Atari, but struggles with continuous action spaces such as traffic light control. DeepQ networks are limited by issues like data correlation and policy fluctuations. To address these limitations, the deep deterministic policy gradient method has been proposed. DDPG combines the actor-critic framework with a deterministic policy gradient, making it well suited for continuous action problems like traffic management. Purpose of the work. The article aims to empirically validate the effectiveness of the DDPG algorithm in optimizing traffic flow management in urban environments. The focus is on comparing the performance of DDPG with Q-learning using a simulated intersection model. Additionally, the evolution of both algorithms over time in the simulation will be evaluated and analyzed. Traffic simulation concepts. To evaluate the methodology, a traffic simulation tool, AIM-SUN is used to model various traffic scenarios, including roads, intersection, and traffic control signals. A traffic simulation network consists of roadways and intersections where vehicles move. Also, the network includes motions, detector simulation, induction loops that gather traffic data like vehicles counts, speeds, and occupancy rates. And this picture, you can see a medium complexity traffic network modeled in AIM-SUN, showing vehicle movement based on green and red signals. DDPG and Q-learning. Most reinforcement learning algorithms rely on the Bellman equation, which forms the mathematical basis for learning value functions over time. DDPG combines Q-learning principles with the actor-critic architecture to manage continuous action spaces. It uses the policy gradient theorem, which states that if the policy parameters are updated proportionally to the gradient of performance, they converge towards a locally optimal policy. To ensure stability in training, DDPG adopts strategies from DeepQ networks, including experience replay, which breaks data correlations by sampling past experience randomly, reverse scaling, which normalizes reward values to a stable range, and target networks, which slowly tracks the learned networks to prevent feedback's instability. Finally, the study shows that DDPG outperforms Q-learning in continuous control tasks such as traffic light timing. This highlights the scalability and effectiveness of DDPG in dynamic real-world traffic environments. Inputs and solution. To ensure real-world... What? 1 minute left. 1 minute left. Okay, I will try to concentrate on a main sense. The simulation is microscopic and runs in discrete time steps of 0.75 seconds, but detector data is aggregated over 120 seconds. The episode step. This step length was chosen through grid search optimization. Experiment setup. To ensure statistical reliability, all experiments were conducted with randomized initial traffic conditions. Each configuration was repeated multiple times, and mean, maximum, and minimum values were used to analyze results. And results. On this picture, you can see algorithm performance compression of the medium complexity traffic networks. On these pictures, you can see intra-episode evolution of DDPG algorithm on the medium complexity traffic network and intra-episode evolution of Q-learning algorithm on the medium complexity traffic network. And conclusion, the objective of this study was to experimentally evaluate the effectiveness of the DDPG algorithm in optimizing traffic flow management in urban environments. The result from the conducted simulation revealed the following findings. The DDPG algorithm exhibited high efficiency and stability within the medium complexity traffic networks. Also, experimental results indicated the DDPG enhances the average reward per episode towards the conclusion of an episode. The proposed evaluation metrics termed the speed score provided a more accurate assessment of the algorithm impact on traffic flow. Despite achieving the study's objectives, certain limitations persist, such as simplicity of the model and the absence of testing on real-world data. Future research should aim to expand the model to encompass more complex traffic networks and to test the approach using the actual urban traffic data. Thank you for your attention.
Yeah, thank you. Thank you for your presentation. So let's have Q&A. I have a question for you. How do you suggest to further improve the performance of DDPG method? Other than trying it out on like some more real complex traffic data, what other suggestions you can make to further improve the performance?
What suggestion I have?
I'm asking what can you make further, like in future research to further improve the performance of DDPG?
Further, what I can do is to test our model on the real data to find some issues, to optimize it, and to use like in real world. Because before I used it only like for simulation. Yeah.
Other than that.
What?
Other than just using real world data, what ideas you may have?
I didn't hear you properly. Sorry.
Yeah. Besides your the other other than the real world data, where you can apply the model?
When I can apply it, or I can if I
we have another one question from another participant. Yeah,
I
please.
have a question. Did you take into account traffic dynamics such as rush hours when collecting data and building the model?
Did I take into account traffic dynamics?
Such as rush hours.
Yeah, sure. When I did my simulation, I used all things that can help me to make this thing better, to use like roads, traffic, rush hours, and etc. Yeah.
Okay.
Because traffic dynamics. Yeah. Okay.
We have one more question.
The question is, how exactly did you train this model? Like, which type of data did you use? How it works? Like, how your algorithm know what to do?
The model was trained using simulated data from AIM-SUN, especially from inductive loop detectors. This provides vehicle count, average speed, and occupancy. The DDPG algorithm receives this data and as input in the form of a speed score, then adjusts the traffic light phase duration to maximize traffic flow.
So you didn't try to use any real like data?
Yeah, and it's like for future, I want to use real data to make it better.
Okay.
Okay, thank you. Thank you for your presentation. Thank you for everything. Now you can stop sharing screen.
For university. Yeah. Thank you.
Yeah, bye. See you there in Kazakhstan. Yeah, and our next speaker is ID 136, Jansere Ikram.
Yeah, I'm here. Hi.
Jansere, could you share your screen, please?
Yeah, sure. Can you see my screen?
Yeah, we can see.
Okay, does it change? Okay, it changes.
And
Okay.
Jansere, before start, I just want to kindly remind you that you have 6 minutes and 1 more minute for a Q&A, okay?
Okay. I thought it's about 8 minutes. Okay, no problem. Okay. Hi everyone. So my topic is depth-guided neural network for robust face anti-spoofing. Firstly, let me tell you why face anti-spoofing is important. Just imagine you have a bank account or eCalf or home face ID, and you try to enter using your face. But let's say this system is not protected, and the hacker comes with your mask. It might be 2D printed or a video attack or mask or deepfakes. Without having face anti-spoofing algorithm inside the system, he or she can easily enter the system and take your credentials or other stuff, take your money or etc. So the background and motivation of the research is so current face anti-spoofing methods struggle with accuracy in different conditions. It might be lightning or environmental conditions, and best average score is about 12% according to NIST evaluation. They have the list of vendors, and the top one showed 12% average score. So let me briefly tell you about the traditional face anti-spoofing, how they tackled this problem. So they used like different histogram analysis. It might be local binary pattern or eye blinking. The system asked like blink your eyes, and the system could analyze the histogram and etc. But after coming the deep learning algorithms, everything has changed. So actually, this research is about deep learning architecture. So the data sets that I used here is there are two academic data sets. The first one is OLU-NPU. It has about 5,000 videos from 55 subjects and from frontal cameras of 6 different devices. So you can see the examples here. The second is called Cassia MFSD, and it has about 600 videos and from 50 subjects. Both of these data sets are academic. Yeah, you can send the request and get these data sets. So the losses that we are optimizing here are binary cross entropy and the mean squared error losses. I'll talk later about this. Where did I use these losses? And the metrics that we are going to improve is, the metrics are APCR, BPCR, and ACR. You can imagine just false positive and false negatives, and the third is like the average of these error rates. So let me tell you about the architecture. This is the custom architecture. Here you can see that it has two branches. First is 3D DFA. This branch just restores, this branch generates the 3D mask from 2D image. This actually is not my work. I got this library from different research and the generated mask for my architecture. The second one is ConvNext. It's one of the state-of-the-art models currently in image recognition tasks. And can you see my screen?
Yeah, we can see your screen.
Okay. So the main goal of this architecture is to reconstruct from the first branch. It reconstructs the mask using mean squared loss. So here I do regression task. The second branch is classification head, where I just do binary
1 minute left.
Yeah, thank you. Binary classification, so 0 or 1. So I just combine these two losses and train my network. So these are the results. The first data set, OLU-NPU, has it has 4 protocols. You can see the results here. The second data set also was trained, on the second data set. And the third one is about about cross-dataset testing. So it assesses the domain generalization. So these are the visualizations of the outputs. Here you see the activation maps. Here you see the depth reconstruction. First row is for bona fide real face. The second one is for the fake faces. So this is the end. As a conclusion, we made a custom architecture trained on 2 different data sets, and the future will be to fix those gaps like domain generalization. It might be different kind of stuff like metric learning or adding some data sets or etc. And yeah, that's it. If you have any questions, please ask.
How do you compare the data?
I cannot hear you. Sorry.
Just tell them how you compare the data with the patient.
Yeah, here we have one question. It says how we can compare the data is literature, right? Yeah, how we can verify that your data with literature.
What is meant by literature?
What is the benchmark? Benchmark. Did you receive the benchmark?
Did you?
What is the benchmark? Yeah.
The benchmark is, as I said, the results are from 4 protocols for the first data set. You can see, I mean, on my paper, it's all written here. You see here all this stuff. So we have 4 protocols here. And this is for the first data set, OLU-NPU. So this is actually the popular benchmark to test in this data set. You can see in each paper related to anti-spoofing, this kind of stuff. So you can go to my paper, read it, and find more information about it. Yeah. I think I answered your question.
Okay, thank you. Next.
Okay. Thank you for your presentation. Thank you for your research. Yeah.
Hey, excuse me. Can I ask a question to organization? Because excuse me, I have examination in 15 minutes. I'll be next shortly, because I'm afraid if I go, I will miss this presentation. I didn't have the 58.
I'm sorry. Could you come again? We didn't hear you properly. Oh, you want to just you want to make your presentation now, right?
Can I be next? Yes, I will next to present work, because I need to go to be free in 15 minutes.
Okay, I think that we can shift your presentation to here. If you are ready, I think that you can start.
Yes, I am ready. Yes, because I need to go. Thank you very much.
Yeah.
See? Okay, now I turn the video. Yes.
You have
Yes,
6 minutes.
see my screen? Yes. My work is development of energy consumption prediction models based on gradient descent methods. Yes. The relevant work, energy consumption prediction, is a key element in efficient energy management, cost reduction, and style development. With a growing scale of electricity usage in residential, commercial, industrial buildings, there is need to create and reliable models that capable of accounting for various influencing factors such as building times, area, number of occupants, appliance usage, and obviously environmental conditions. So while classical machine learning methods like decision trees or neighbor algorithms are widely used, they often lack necessary accuracy and are often too sensitive to data structure. So in this context, optimization methods based on gradient descent deserve particular attention. Although extensively applied in other domains, they remain underexplored in building energy prediction tasks. So evaluating the effectiveness and comparing with them with other approaches allows to determine the potential for integration to future energy systems. The objective work is to develop these energy consumption prediction models based on gradient descent methods and evaluate the efficiency in comparison with other popular approaches. So task they need to be done is implement test models using standard gradient descent, momentum, Haber-Bosch, Nesterov methods. According to formulas will be in the next slides. Apply ridge regression with L2 regularization. L2 regularization allow us to avoid the overfitting of the data and comparison the result with other machine learning methods, decision trees, random forest, KNN, and assess models obviously performing using metrics, MSE, RMSE, R-squared metrics. So data preprocessing. So what data set we have? We contain features with building type, square footage, number of occupants, appliances used, and average temperature and day of the week, and the target variable is every energy consumption in kilowatts. So pre-processing steps was done. It's one hot and cold for categorical features like building times. We need to transform into numerical features. Normalization, because it's needed to the gradient descent optimizations. It's necessary to the scales of the features do not differ. And additions of bias columns, they consist of ones. It's to necessary for optimizations, gradient descent, to compute the intercept equation. And obviously splitting gradients and test sets. Methods, standard gradient descent methods is standard, momentum, Haber-Bosch, Nesterov, and other approaches. Machine learning is decision trees, random forest, and KNN. And ridge regression, what we have cost function is a regression corresponding formula on the screen. So this formula of the gradient descent standard, momentum with momentum, Haber-Bosch, and Nesterov. For example, Nesterov, we compute the gradient on the future point. Evaluation metrics, the performance of the model was assessed using classical regression metrics. MSE and RMSE show the average error, and the coefficient determination, R-squared, reflects the proportion of variance in the original data that's explained by the model. The closer R-squared to 1, to better the model fits the data and explains variation. Following formula, corresponding formula on the screen. And the result, we have a table. As you can see from the table, the best results shown by the Haber-Bosch method, with the lowest MSE, RMSE values and correspondingly higher R-squared. The rest of gradient descent modification also show very high accuracy, while classical ML methods such as decision tree KNN are significantly inferior in quality of predictions. So conclusions, as a result, the study models for prediction building energy consumption were developed based on gradient descent methods and its modifications. And ridge regression was implemented as an option with L2 regularization. The full modeling pipeline was implemented from data preprocessing to evaluation of prediction quality using metrics MSE, RMSE squared. The result demonstrated that all gradient descent methods provided higher prediction accuracy, with Haber-Bosch method achieved the lowest error value. A comparison with other machine learning algorithm, random forest, KNN, decision tree revealed a clear advantage of gradient descent based approaches in this task. Thus, the study confirms the effectiveness of using gradient methods in regression problems for predicting building energy consumption and demonstrates the superiority over classical approaches. Thank you for your attention.
I have a question.
Okay.
So your pipeline is quite original. What is the novelty of your paper?
Novelty?
Novelty of your paper.
Novelty of the paper is we use the gradient descent method optimization. It's not very often used in this task for prediction, machine learning problem in energy task. Obviously, if you see the prediction in this domain, obviously used the random forest, KNN, and others, but we show that we used gradient based. They show high accuracy and reliability of the model if we format correspondingly cost function.
Thank you, but for my opinion, it's quite common approach, but maybe you implement some details.
If you, for example, if you implement basic regression in this task data set, the basic regression very shows that high overfits. So that's why this
and but if you use optimization, not using the analytic approach and optimization iteration method, they show that the overfitting go off.
Thank you again.
Okay, thank you. Do we have any other question, please? No. Then thank you for your presentation.
Thank you
It
very
was
much.
quick
Thank you
and
for shifting
valuable.
my work. I appreciate it.
Yeah. And our next speaker is with IT 145, Alia Alokova from Astana IT University. Alia, could you share your screen, please?
Yes, now I share with my screen. Do you hear me?
Yeah, we can hear well.
Okay, do you see my screen?
Yeah, give us a second, please.
Not yet.
Yeah, we can see your screen.
Okay. Hello, my name is Ilya Kalakulova. I present the topic Term Unigram Extraction using embedding-based filtering. This is content of my presentation, so let's get started. The amount of text data is growing and it's becoming impossible to process them all manually. Therefore, different NLP tools are being developed. Term extraction is a fundamental step in such tasks as machine translation, classification, structuring of document, construction of knowledge graphs, etc. One of the main challenges is noise into text data. General words such as usually, a lot, very, much, etc. Words don't make much sense information without context. And the goal of my research is to develop an efficient unsupervised annotator for single word terms and test its efficiency on the different texts and languages. Term extraction approach can be divided into two supervised and unsupervised approaches. Supervised ones use machine learning. They are more accurate, but require a lot of computational resources and label data. They also depend on topic of the training corpus. Unsupervised methods don't need any label data suitable for different domains. They rely on part of speech, semantic, and frequency metrics. However, they infer in quality to supervised ones. The developed approach was tested on open active dataset containing text with labeled terms in 4 topics and 3 languages. Since the unit text annotator extract only unigrams, compression was made only with true single word terms. This shows a small example of how corpus data looks like. The texts are presented as TXT format documents, and the terms, true terms, are given as a list of unique terms per domain and language. The unit-text approach uses word embeddings. It represents of word meaning as numbers. If words are close in meaning, they are located closer to each other, and vice versa. If they have different meaning, they are further away from each other. One way to measure the distance between word embeddings is to measure the cosine angle between them, or cosine similarity. In NLP, the value varies mostly from 0 to 1. The input of unit text is text or corpus, and the output is list of terms. First, the text is tokenized and tagged with part of speech text. Candidates with post-text, noun, proper names, adjectives, adverbs, and verbs are extracted. And then candidates are cleaned of digits, punctuation, etc. The static vector machine is used to obtain embedding for candidates and stop words. After each candidate is compared with each stop word. If at least one stop word has cosine similarity greater than 0.5, the candidate is rejected. That is, the candidate must have a similarity less than 0.5 with all stop words. Then the candidate is classified as term. To evaluate the approach, we will use measure A1 score, which provide a harmonic mean between precision and recall. Precision is percentage of true terms among the extracted terms. Recall is percentage of extracted true terms compared to all true terms. The unit test has been compared with some supervised and unsupervised approach for extracting single words terms on the actor dataset. The supervised approach mostly outperforms the UNITEX results. However, the gap is much smaller compared to other unsupervised approaches. UNITEX outperforms the unsupervised approach and also much supervised approach in certain cases. Here is shown how the performance of on English text on heart failure topic changes when the threshold of similarity with stop words is varied. If the threshold is increased, the retrieves more words. If threshold is decreased, the precision increase. In conclusion, UNITEX demonstrates competitive result compared to supervised approach. UNITEX depends on model quality, which provide embedding and embeddings, stop word list, and similarity threshold. This annotator can be used to clean up noisy words and identify informative one. So here my reference, which I use in presentation. Thank you for your attention.
Yeah, thank you for your presentation. Now we have section Q&A. I have a question for you. What are the inferences and observations that you made as a result of your research work? Which conclusions have you made comparing different approaches used for this task?
Can you please repeat the question?
What are the inferences and observations that you made, after using all the possible methods for your task, and how can you further use the results of your research in the future?
How I can use it in the future? So, for example, it can. Yes, you mean how it can be used in the future? Yes.
Yeah. Continue.
This can be used, for example, to extract phrases by detecting informative words. It can be used to detect the topic of the text because it removes noise words and extract only informative. And it can be used, for example, in machine learning. We can use cosine similarity between stop words, and it can help be like feature to detect terms.
Okay, thank you. Do we have any other questions? No. Then thank you for your presentation.
Thank you.
You can stop sharing the screen.
Okay.
So our next presenter, the next speaker is with ID 146, SDU University. Yeah, you are and then here, right? 46. And yeah. Yeah, please stay closer to microphone. Yeah, thank you.
Hi, and I'm a master's student at the university, so I work with Khaled Mohammed. He's actually here also. So the topic of my paper is the comparative analysis of statistical machine learning deep learning models for PM2.5 prediction. So here's the brief content of my presentation. So in this paper, we collected data between 2020 and 2024 for 4 years, and trying to find the most accurate model for predicting PM2.5. So first, let me explain what is PM2.5 first. So it's a very small component in the air which depends on the air quality. So in this picture, you can compare it with the human hair and compare their sizes. And this I want to say that 7 million deaths annually are linked to the air pollution by WHO, which is World Health Organization. So that's why it's very mandatory, like predict in the right way. We all know that Almaty is the most polluted city in Central Asia. Its PM2.5 level is 5 times higher than the safe limit. So here is actually photo how Almaty looks usually. To solve these problems, we identified the three objectives. Like first is to collect, process, and align historical PM2.5 and some methodological data from Almaty. Second objective is to develop and compare all models. Then to evaluate and find the most accurate model. So we all the researchers, like this experiment was done in well-resourced regions like North America, Europe, and East Asia. But in the case of Almaty, it's not like this because we have some problems with our data, like missing values. Also, I want to specify that Almaty has like unique geographical location because it's surrounded by mountains. Also, I hope this work will help to achieve the national relevance, like support Kazakhstan's path to carbon neutrality by 2050. So here's some brief literature review. So here's similar experiments in other countries like Iran, United States, China, Taiwan, Vietnam, and South Korea. The key findings is CNN, LSTM models, random forest models, and the XGBoost achieve the most highest accuracy. So I split the methodology into 6 steps. So in the first, it is data collection. So data was collected between 4 years, 2020 and 2024. It's approximately 1,600 daily reports. The data was collected in the aqicn.org website and the cathhydromet.kz. So all the chemical elements was taken from aqicn and the meteorological data from cathhydromet.kz. So after collecting all the data, it was merged by date. Then we have problems with missing values because the missing values is continuously. So the most biggest one is for 3 months between May and September. So that's why we decided to use 3 imputation methods for such missing values. First is mean imputation, like average mean. Then the time-weighted mean, which takes the same day from the previous years, for example, and find their average and put it when it's missing. And the third is Miles imputation method. So it works like a regression. Then we select the features and then analyze data to test and train them. So here is the data, how it looks after after we fill out all the missing values. So for example, in the first mean imputation, it's not like realistic. The Miles is most realistic one because it has also outliers, which is very normal for weather data. Here is the list of models that was tested. So this is detailed information. We can skip it because it will take a lot of time. Then we evaluate the data using the MAE, LNC, and the R-squared to find their accuracy. So here is the all results. So scenario 1 means mean imputation, scenario 2 means like time-based mean imputation, and the scenario 3 means Miles imputation method. So by the results, the scenario number 1 mean imputation, for scenario number 1 mean imputation, the best model was random forest. So it can handle with the noisy oversmooth data better than others. And it performed well despite the loss of seasonal variability. And for scenario 2, time-weighted mean interpretation, the best model was CNN ELM. It is hybrid model. So it captures the signal patterns and the non-linear trends. And it shows more like accurate results. And the best one over the all models was with the wide interpretation method, LSTM. So okay, so it can work with the temporal dependencies. Also, it shows the most highest R square for my data. So here's the main three best models. So we see that LSTM shows the best result, 95%. So by the discussion, I want to mention that my simulation method was the best because it shows higher accuracy for most of the results. So you can see it in this table. And by the conclusion, I want to say that LSTM really works well, but I want to continue working with the hybrid models because they showed the lowest error. So that's why I think hybrid models can show more like best results in the future. So that's it. Thank you for your attention.
Thank you. And let's have questions. Do we have any questions? For this presentation? Do you have any question, Devlet? No?
Okay.
Considering that even though deep learning models are good, they are like associated with carbon emission though. So having that you have motivation regarding ecology, I really think it would be better to stick with something like more classical machine learning approach. So to address that, how can you further improve your work? Like improve the results from like machine learning, like simpler algorithms?
I want to mention that my dataset is very like small for deep learning, so that's why it like every time sensitive, very sensitive. For example, if you look at the result here, so in the second scenario, it shows even like minus accuracy because of the data limitation. Yeah, because I want to mention that like more easier like statistical models are showing the most more stable results. Yeah. So in the future, it will be better like to solve this problem with data limitation. After that, I can answer for your question.
Have you addressed the question like the problem of scarcity of data? Like, did you consider like methods to like collect the data? Possibly like how can you obtain the data from Almaty? You know, which how can you address the issue of data scarcity that you are mentioning? I mean, the lack of data. How can you obtain more data?
Lack of data. So it was only the available data, but I think for open source, it was the only available data for open source.
Yeah, like not open source. How can you get other data?
I think we need to talk with government or to take like more data because it like closes.
So, did you try to find these data, which is lack, and find from, I don't know, nowadays we have a lot of satellite data sets. Is it possible to find in there?
I tried to find only real data. Yeah.
And I think when you try to fill in your missed values, I mean, data set by average value, anyway, you will have some problems in predictions. So then I see here that you use multiple linear regressions. So as input, what kind of additional parameters do you use?
All of them. Okay. So it is PM2.5 and some chemical elements without the PM10. Also temperature, humidity, wind speed, pressure.
And how do you clean, in this case, your data set only for example, your target is PM 2.5. So how do you determine this value, I mean, data from others? If is it given in general, or did you clean it by yourself for PM?
By myself, yeah.
By hand or after?
By hand, so it was like separate for PM 2.5,
Okay.
for NO, for SO.
Okay, thank you.
Okay, do we have any other questions?
I think these parameters is possible to get in how it goes, Copernicus.
It is like available data for all time. The problem with AQICN.
So if you use as input parameters like temperature, humidity, it's possible to find in Copernicus. Try to give the coordinates of Almaty, and you can upload for any years historical dates. If you can clean it after only 4 p.m. Okay.
Okay, thank you for your presentation. It was really valuable. And our next presenter is with ID 147 is Ramazan Dusinbek from Astana IT University.
Hello, good afternoon. Can you hear me?
Yeah, we can hear you. Could you
So
share
let me
your
share.
screen, please?
Yeah, I would like to share my screen first.
Yeah.
Is it visible now?
Yeah, we can see your screen, yeah.
Yeah, cool. So let me start. So my name is Ramazan Dusinbek, and the paper that I have written and submitted is real-time Kazakh Sign Language alphabet recognition using SVM and YOLO V8 Nano. So first, let's start with an introduction. First of all, the problem, let's start with the problem statement. Kazakh Sign Language lacks real-time recognition tools. So it has been studied very less, and there are very less papers and works, research that are done in this field. So let me talk about the actuality of the problem. First of all, we can talk about the numbers. So in Kazakhstan, there are around 200,000 individuals with hearing disabilities. So the goal of my project was to detect and classify Kazakh Sign Language alphabet signs in real time. So that's the main goal. And the methods that I have chosen are, so I have chosen SVM for just classification of images and YOLO version 8 Nano for real-time detection. So maybe some of you might have questions why 8th version, even if we have 11th now. The project was implemented last year, so I have finished only now. Now, let's start with dataset description. So the dataset, in Kazakh language, we have 42 letters. And the dataset contains 50 images for each, making it 2,100 images in total. So the dataset was taken from the second source. And we can see the letters on the left top side. Methodology. So first, I have chosen YOLO for real-time detection. It is a lightweight version for real-time performance. I don't have that much data, only 2,100 images, and this model performed best. So what I have done, the model detects a hand region in the image frame, and the model is trained on these images. And SVM for classification. So classification was done by dividing the dataset into training and testing sets. So this is the architecture of my research for YOLO. First of all, that dataset is divided into training and validation in 80 to 20% ratio after each image is labeled. So labeling means the main part of the image is taken into TXT format. So it means like it contains 5 data. First, class ID, X center, Y center, height, and width parameters. So 2,100 TXT files were created for each image. After we start training the model, so we create also .yaml file that has directions for this dataset and evaluate the metrics. After training the model, we have to just download it and test it in real time. And after testing, I took screenshots from each gesture and made a collage. So first, let's start with SVM. So SVM was done just to classify each image. So it's a lightweight version, and SVM is a popular model. So it made perfect score, getting 99% accuracy rate. But however, there were some similar gestures. For example, in Kazakh, we have similar letters like A, E, K, H, and etc. And model made some errors in these regions because the gestures look really similar. So the next result is confusion matrix for YOLO. So this is the validation dataset confusion matrix. There were also similar gestures and background class. As you can see in confusion matrix, we have one more class, background. So background class means there were some images that the model was unable to detect or like classify. So the model created one more class, background, and just classified there. And we can see like all the letters are along the main diagonal, meaning that it made a high accuracy result. So here we can see performance metrics. Here we have training loss, validation loss that as epoch goes on, that they decrease. And we can see precision, MAP, and recall metrics that went increasing as the epoch also extends. So here is the screenshot. So I have downloaded the model and took screenshot of each gesture. So the confidence score was ranging from 81% to 98%. So confidence score is similar to accuracy rate, in fact. So it is a multiplication of like the object is detected and that object or that gesture is belongs to which class. So the multiplication of these two. So I got confidence score of this much. So comparison of methodologies for Kazakh Sign Language recognition. So here I have taken the works that use SVM and the works that mostly had real-time scope. So as we can see, these works were done in past, but as time goes on, we can see that the latest works are performing better, and there is a key contribution. So the key contribution of my work, or the novelty of my work, is that this is the first real-time Kazakh dactyl alphabet recognition using YOLO model itself. And in conclusion, what I would say is we have to pay more attention to this field, and for future works, we have to extend to full word recognition, and then to sentence recognition. Also, we need more open source datasets and try other different models. So this is my reference list, and thank you for your attention.
Thank you. Thank you for your presentation. Okay, so we have a couple of questions here. And as we understand that your model recognizes the letters as well as the words, right?
No, it recognizes only letters. Words, to be honest, I have done another project and we have published already. We have taken question words like what, when, who, why in Kazakh. So we have done 8 words. I mean, we have taken 8 words and used the same model and also already published that paper. But in this one, I'm taking only letters.
Oh, okay. Because as far as we understand that in open sources, there are available the model which recognizes also the Kazakh words. And please, if you're going to in the further do this research, take into account that the Kazakh people, 90% of Kazakh people doesn't speak Kazakh fluently. I mean that they would add the additional Russian words that you need to somehow make the model mix up models because nobody speaks Kazakh 100%. And this is very important. Yeah.
Yeah, I got your point. Thank you.
Another question for you. You just use the YOLO V8, 9, and architecture, right? You didn't make any changes from your part,
No,
right?
I haven't done any changes. Just YOLO version 8 and Nano. Why not?
What updates or changes can you make to the model? Like, for example, change the model depth and width, like something like that.
Regarding the model, yeah.
Like in your further research, how can you enhance the performance of this YOLO architecture? Like, what updates and changes can you make?
I think it would be better to take the latest versions. This is 8th version. It was, if I'm not mistaken, 2 years ago. I mean, it was released 2 years
I
ago.
don't mean just taking the ready architecture from the internet, like from your own part. Like, which updates or changes can you make to the architecture itself?
In architecture part. For example, I would add data augmentation, for example, because when you rotation, especially, because when you look at the camera, maybe the data set was taken in for example, I don't know, maybe not 90 degrees, but 80 degrees. So diverse data set is needed. That's the first thing that comes to my mind, to be honest.
Okay. Thank you for your presentation. Thank you. It was really valuable and a good presentation. And you can stop sharing the screen. And our next speaker is with ID 151, Artur Markov from Taras Shevchenko National University of Kyiv, Ukraine. Yeah, Artur, now you can share the screen. Please give us a minute.
So can you hear the presentation? Can you see everything?
Yes.
Okay, so let's start. Hello, everyone. My name is Artur Markov from Taras Shevchenko National University of Kyiv. In this presentation, I will share our work on improvements to sequential approaches in A/B testing, making it more statistically reliable and easier to use in practice. A/B testing is a gold standard for causal inference in online experimentation. It uses randomization to align users into groups, typically a control and one or more treatment groups. Scientifically speaking, A/B testing involves parametric or non-parametric hypothesis testing to evaluate differences in outcomes, such as conversion rates. Before running the experiment, a target sample size is usually determined. The test results are only analyzed once that sample size is reached. This is known as fixed horizon approach. However, such approach has limitations, particularly in real-time environments. That's where sequential testing methods became more useful. They allow for continuous monitoring while preserving statistical validity. In practice, we need to monitor experiments continuously, especially health metrics like bounce rate or server errors. Waiting for fixed sample size isn't practical when quick action is needed. Sequential testing allows ongoing evaluation and early stopping, making it ideal for real-time decision-making. In this work, we focus on two sequential approaches: BI-SPRT, this is Bayesian interference sequential ratio test, a frequentist method using Bayesian estimates, and Bayesian sequential, which updates decisions based on expected loss. BI-SPRT, proposed by Yana Bondarenko, combines Bayesian estimation with sequential likelihood ratio test. The key idea is that the sequence of likelihood ratios under the null hypothesis forms a martingale. This allows the use of dupe inequality to define a stopping rule, which in our case means it's highly unlikely to observe likelihood ratio values higher than the select threshold. However, such inequality only provides an upper bound. It doesn't define the threshold precisely. When we tested this method, it significantly overestimated its confidence, resulting in inflated false positive rates. To fix this, we derived a correction function using simulation linear regression. After applying it, the false positive aligns with the target, and the test performs reliably. Despite its improved reliability, BI-SPRT complexity limits its use in BI platforms. We observe that its confidence intervals closely resemble those of the test scaled by constant.
On the figure above, you can see z-test confidence intervals colored orange and the BISPRT intervals colored red. The green is approximation using the constant. This allows us to implement BISPRT in system like Tableau Amplitude using only simple formulas. On figure below, you can see the implementation of the adjusted BISPRT test in Amplitude using custom formulas functionality. Without the following adjustment, it would be impossible to implement BISPRT test in this BI platform. We also ran a simulation to test how sensitive Bayesian sequential test is. We found that false positive rate stays below 5% only when threshold was extremely small. Higher thresholds led to inflated positive rates, especially under continuous monitoring. Based on these results, we recommend the following thresholds to keep error rates under control. These findings align with similar researchers and highlight the challenge of tuning Bayesian sequential methods reliably. In A/B simulations, both BISPRT and Bayesian sequential showed significant sample size reduction compared to the fixed horizon method. Bayesian sequential tended to close tests faster at high lift level due to its design. BISPRT, on the other hand, performed exceptionally well at low conversion rates, a pattern also observed in previous studies of SPRT methods. As the base conversion rate increases beyond 25%, Bayesian sequential achieves greater sample efficiency, while BISPRT's advantage diminishes. On conclusions, BISPRT was improved through simulation-based correction of the stop-in threshold. Confidence intervals approach was approximated, enabling easier integration into BI platforms. For Bayesian sequential, AA simulations identified optimal stop-in thresholds to control false positive rates, but limited compatibility with BI system make it less practical. Overall, the corrected and approximated BISPRT method offers reliable type 1 error control, computational efficiency, and strong applicability for real-time A/B test monitoring. Future work may focus on improving the interpretability and deployment of Bayesian sequential methods in commercial experimentation platforms. That's all. Thank you for your time. I'm ready to answer your questions.
Okay, thank you for your presentation. Now let's have a questions. We have one question from here.
So can you elaborate more about the simulation that you used for correction of stop-in threshold? Like how did you conduct it? Like which software did you use? I'm curious about.
So basically, regarding simulation, I use Python as a software. And so let me dig into here. Yeah, so as you see, I ran 5,000 simulations. As I remember, it was 5,000 simulation for each pair, and I control the mean, and I control the amount of false positives, yes, and after that I found the false positive rate. The same simulation I also did after I did a correction function, and as you can see, I did more simulations to test it more deeply. And the same simulation I did for Bayesian sequential tests. And regarding the algorithm and all of the sums, I listed everything on my paper, so you can check it out here. There.
What are your future research perspectives regarding this? How will you further?
Can you repeat the question, please?
Like, what are your future research perspectives with your topic? Like, what can you do?
Yeah, so my further work will be regarding evaluation and simplification of the Bayesian sequential method. So the main problem with Bayesian sequential is this threshold. So we need to define it and test it more deeply. There was no easy solution like for BISPRT method. And also the threshold and the decision rule for Bayesian sequential is differs from the other method because we're operating as an expected loss. So amount of conversion we may lose. And for other methods, we see the false positive. So it's slightly different terms. And in terms of explaining it in practical, explaining expected loss, it's much harder than the false positive rate.
Okay, thank you. Okay, thank you for your answer, for your response. Thank you for your presentation. Now you can stop sharing. Our next speaker is with ID 157 from Astana IT University. David, could you share your presentation, please?
It would be more convenient if you share my presentation.
Okay, okay.
Could you hear me well?
Yeah, we can hear you. Now, is it visible to you?
Yeah, it's great. Thanks.
Yeah, now you can start.
Okay, so hello, I'm David from Astana University, and today I will walk you through our comparative study of cloud-based versus local large language models of social media sentiment analysis. Please, could you, next slide, please. Yeah, so social media is like goldmine of public opinion, but analyzing it is trickier, and traditional methods fail with sarcasm or internet slang, and LLMs offer a better context handling, but we still don't fully understand which deployment is the best, so cloud or local. Next slide, please. So we choose AI-generated art and cancel culture as our two case studies, gathering comments from YouTube, TikTok, and Reddit. First, we ran a quick text blob analyzing, like to set a baseline. Then we post the same structured prompt to 4 LLMs. It's GPT 4.0, Gemini 2.0 Flash, Llama 3.2, and DeepSeek R1 7 billion parameters. And compare their reports side by side for sentiment, accuracy, thematic depth, and platform-specific insights. So next slide, please. Yeah, so we gathered over 14,500 comments from YouTube, TikTok, and Reddit, targeting discussions on AI-generated art and cancel culture, as I mentioned before. After filtering our deleted entries, spam, and metadata, we retained nearly 30,800 high-quality comments. And can you, next slide, please. So as the chart shows, cleaning moved about 3.5% of YouTube data, but nearly 15% of TikTok comments. Next slide, please. So after establishing our sentiment baseline with the text blob, we submitted the exact same cleaned data set and structured prompt to each of the 4 LLMs. And we evaluated their outputs on, firstly, is how closely the overall sentiment matched our baseline that we get from text blob. And the second one is the richness of their thematic and emotional insights. Next slide, please. So on the topic of AI-generated art, over half the sentiment was positive, reflecting optimism about creativity decommunization, and roughly 22% comments expressed negative concerns, which like touch the topics of copyright and job displacement, while the remaining 22% stayed neutral. Next slide, please. So cloud models captured nuanced ethical debates, whereas local models mirrored these percentages most closely to the text blob that was baseline. Next slide, please. Public opinion on the cancel culture is more divided, and about 39% of the comments support accountability, but 36% view it as overreach. With 25% remaining in like neutral or ironic opinion about it. Cloud LLMs, next slide, please. So cloud LLMs excelled at contextualization ideological roots, while local LLMs provided like a clear quantitative breakdowns of platform-specific backlash. Next slide, please. So in the conclusion, our findings reveal that no single deployment excels on all fronts. So cloud LLMs deliver richer context and ethical nuances, and local LLMs offer privacy and precision in statistical outputs. So we envision a hybrid sentiment analysis tool that initially screens data locally, then invokes cloud models selectively for like deep dives balancing between like privacy, cost, and insights. Like it will be like a single tool when you just enter the topic name and it gives you the reports from and local and cloud-based AI LLM models. That's all. Thank you for your attention.
Thank you, David. Do we have any?
I have a question. Yes, I have a question. Please, could you move for the previous slide? So I would like to know what means these percents. So
yeah, okay, I can explain. So the first bars says that it's text blob. So we run our like base of the comments through the like Python script that was to sentiment divide them on positive, negative, and neutral. And after we're getting reports from LLMs, usually they like have a percentage. So we in the prompt we ask them to like get back the percentage of sentiment analysis. So that's what it's showed on the graph. And you can see that the ChatGPT 4.0 model was the closest to the our baseline text blob.
this is accuracy, or maybe F-score, or maybe precision. What means these percents?
This percent means that the local or that cloud-based LLM was able to like identify the same level of the sentiment analysis emotions from the text. So it's the same. If we get the same answer as from the text blob, it means that it was like really digging into it and not like just predicting an answer.
It is not common representing of the results, because you should add maybe confusion matrix, or maybe ROC curve, or maybe precision recall matrix, but this is this is not common. This is not common visualization for your results. So is this
we're getting the answers in the report in the text. Is this like a graph? It's just a visualization to get a quick overview of what answers we get from the reports on our like chosen topics, and was it like close enough to the text blob or not? I understand that like this is not like a big like investigation, and it will be like improved in the future. As I said, that we are planning to create a tool. I understand that this like, yeah.
What is the ground truth of your models? Ground truth of your sentiments, and ground truth for your models. So what is the best model, or what is the?
Yeah, it is not like a clear answer, because as I said, for the like more deep dive and emotional insights, it's best to use cloud-based LLMs such as Gemini 2.0 Flash and ChatGPT 4.0. But for the like more number-based, it's best to use local LLMs, which has less like number of parameters, but it's like more straightforward.
Thank you.
Okay, thank you, David. Thank you for your presentation. It was
Thanks.
really, dear all participants, online or in person, we happy to inform you that our first session is over, and we are going to continue tomorrow at 2:30 p.m. Yeah, hope to see you there. Bye.
Thank you.
Goodbye.
Короче.